Alright guys, sorry I can't be here with you today, but we are going to review right triangle trig from geometry. Just a little review before we get into our trigonometry unit. So this warm-up I would like for you to try. It says, given the measure of one of the acute angles in a right triangle, find the measure of the other acute angle. So I want you to talk about that with your partner. A couple things to talk about. One, what is an acute angle? And two, what does a right triangle have to do with anything? Once you've talked about those two things, see if you can answer 1 through 4. Okay, let's do just a quick check and see where we are, and then I'll give you a couple more seconds to see if you can answer these. So the first thing is we want to draw a right triangle. So a right triangle looks something like this, and we put the right angle marker in the bottom corner. And what do we know about the angles in a triangle? I hope we remember from geometry that all of our angles add to 180, okay? And with this angle right here being 90, that means our other two have to add to 90. So quick example, and then I'll let you do the rest of them. 45 plus what equals 90? That's the question you're asking yourself, or 90 minus 45, which is 45. Okay, so take about 30 seconds and answer the last three if you have not. Alright, so let's just do a quick check. So 60 plus 30 would be our other angle here. 24 plus what? That would be 66. And 38 plus what? That one would be 52. Okay, so that's just a quick review of right triangles and angles and what they add to in a triangle. So now let's do a quick review of sine, cosine, and tangent. So I don't know if you remember, but sine, let's draw our right triangle first. We have a right triangle, okay, and I'm going to put a little marker in one corner. We're going to do all of ours based off of this angle here. I don't know if you remember this, but when I learned right triangle, trig, sine, cosine, and tangent, we learned it by this acronym. So, ka, toa. So what does that stand for? I hope you remember this. Sine of our angle is equal to opposite over hypotenuse. Cosine of our angle is equal to adjacent over hypotenuse. And lastly, tangent is equal to opposite over adjacent. Okay, now whenever you're looking at the triangles, in order to name sine, cosine, and tangent, you have to put yourself at the angle and ask yourself the question. So if we did that here, if I put myself at this angle, then my opposite would be here. Okay, my adjacent would be the one right next to it, the leg right next to it, and then the hypotenuse is always the hypotenuse. It does not change its location. It is across from the 90. Okay, so let's look at example 1, and then I will let you try 1A, and then I'll let you try B. So mark where your angle is, because everything that we answer is going to be based off of that angle. So I'm going to go ahead and write, that little symbol, by the way, is theta. So sine theta is just the Greek letter for angle. Cosine theta, tangent theta equals. And these are just going to be fractions. We're not punching anything in on our calculator right now, okay? So if I place myself at this theta, then the 7 is my opposite, the 24 is my adjacent, and the 25 is my hypotenuse. So you can actually label that if you need to. So when I'm answering sine, sine is opposite over hypotenuse, or 7 over 25. Okay, now we always want to make sure that this fraction cannot be reduced to 7 over 25, and it cannot. My cosine is adjacent, which is 24 over 25. And then the last one I have is tangent, which is opposite over adjacent, or 7 over 24. Okay? Alright, now I want you to look at B, and I'm going to go ahead and write out my sine theta, cosine theta, tangent theta. Put my equal sign with my fraction bars. I'm going to go ahead and write all of that out. Okay, I want you to be careful when you're answering this one. Notice that my theta is up here in the corner. So my opposite is not going to be the 16. The opposite is going to be the side opposite that angle that I just marked. Okay, so take just a minute with your group, with your partner, and see if you can answer these. Alright, so my sine is going to be opposite over hypotenuse. So my opposite is 30. My hypotenuse is 34, which reduces to 15 over 17. Please make sure you reduce. Okay. Next I have cosine. The adjacent is 16 over the hypotenuse is 34, which when I reduce that, it's 8 over 17. And then my last fraction is opposite over adjacent, or 30 over 16, which reduces to 15 over 8. So I hope that we remember that from geometry. Okay, let's talk about another thing with triangles in geometry, and that is special right triangles. Oops, went too far. Okay, in geometry, we have two special right triangles, and I'm going to draw them up here. So if you'll draw them on your paper. Okay, the first one that we have is the 45, 45, 90. 45 degrees, 45 degrees, 90 degrees. This one is the easy one because with a 45, 45, 90, you have two legs that are the same length and then a hypotenuse. And here's what their lengths are. 1 to 1 to square root 2, or we write their ratio 1 to square root 2, which is the leg to the hypotenuse. Another way to write this would be 1 over square root 2. Okay, I'm sure some of you are starting to remember this and not being very fond of it because it is a little difficult. Okay, I'm going to grab the pen for just a minute, so you're going to have to deal with the clicky sound. Okay, and let's write the rest of these. So the other triangle that we have is the 30, 60, 90. So 60, 30. The 30, 60, 90 has a short leg, long leg, and hypotenuse, which has the ratios of 1 square root 3, 2, or 1 to square root 3 to 2. Now, the interesting thing about this one is that you can't do all of those ratios at one time, so you have to decide which ones you want to use. Short leg, long leg, hypotenuse. Oops, I just realized I got these backwards. Fix these really quick. It is the short leg is the 1 and the long leg is the square root 3. Alright, got them backwards on my picture. Okay, so here's how you know which one is which. The short leg is always across from the 30, so I'm going to highlight that. The 30-degree angle matches with the short leg of the triangle. The 60-degree angle matches across from the long leg. And then the hypotenuse is still always across from 90, just like always. Okay, so let's try two of these examples. So my first triangle that I have here, is the 30, 60, 90. So I'm going to go ahead and label that. Across from the 30 is the short leg. Across from this angle has to be 60. This one's the long leg. Across from the 90 is the hypotenuse. Okay. If I look at my picture, the short leg is a 1 and the hypotenuse is a 2. Okay. And those are the only two I need. I don't care about this long leg over here. They're not asking me to solve for it. So here, this now is really easy once you get your labels. We're going to make a fraction. 74 over x equals, and then here's your other fraction, 2 over 1. Then it becomes a cross multiply problem. I'm going to cross multiply here. So 74 times 1 is 74 equals, and then I'm going to cross multiply the other direction. Oops. The other direction. X times 2 is 2x. Divide by 2, divide by 2. So x is 37. Okay. So there's one example of 30, 60, 90. Here's what I don't want you to do. If you're dealing with the square root 3, I don't want you to punch that in your calculator. I want you to use fractions if at all possible. Okay? Alright, let's look at B. B is the 45, 45, 90. So leg, hypotenuse. We have 1, 1, square root 2. Okay, so now let's make some fractions. Here's my first set. 20 over x equals, there's another fraction, square root 2 over 1. Alright, here's what I mean with I want you to use fractions and not do decimals, okay? So cross multiply, 20 times 1 is 20, equals, go the other direction, square root 2x. Alright, now here's where you got to remember for some algebra stuff, okay? Divide by square root 2 on both sides. So I get x equals 20 over square root 2. Okay, now here's an issue. We know we don't leave square root 2 in the denominator of a fraction. So I'm going to rationalize that by multiplying by square root 2 top and bottom. So that gives me 20 square root 2 over, now we also know that square root 2 times square root 2 is just 2. My last step is to divide those. 20 divided by 2 is 10 square root 2. Okay? These are the hard ones. These are the hard ones on the homework the ones that look like this. Okay? So I just want you to try them, try to remember them, and if you have questions, we'll go over them tomorrow. Alright? Let's try a couple word problems. And I know you're freaking out because it said word problem, but here's what I want you to remember. I want you to remember that if I know SOHCAHTOA, if I know what sine, cosine, and tangent are, I can answer this question. Okay? So let's look at number 3. In a water skiing competition, a jump ramp has the measurements shown. To the nearest foot, what is the height h above water that a skier leaves the ramp? So here's the nice thing about this one is that they already drew the picture for you. Okay? So now we just have to answer the question. So here's what I always do. I always put a dot or put my finger at the angle, okay, which is right here. Right here at this 15. There's my angle, okay? The question is, what is h and what is 19? Opposite, adjacent, hypotenuse, okay? And if you look at your picture, h is the opposite, 19 is the hypotenuse. That would be sine. So sine, now sine, cosine, and tangent are always followed by an angle. So sine 15.1 is equal to the opposite h over the hypotenuse 19. Okay? Once you get this problem set up, it's easy from here. Okay? We're going to put this sine over 1 and cross multiply. 1 times h is h equals, now go the other direction. This looks like 19 sine 15.5. Okay, now we are going to go to our calculators and type that in and estimate it. It says to the nearest foot, so no decimals. But here, before you start typing in your calculator, I want you to make sure that you are in degree mode, not radians. So hit the mode button at the top of your calculator and make sure that you're in degrees, not radians. If you don't know how to change that, please ask somebody around you to help you change your calculator. The rest of you, let's go ahead and type in 19 sine 15.1. Okay. So when I type in 19 sine 15.1 in degree mode, to the nearest foot, I got 5 feet. I got 4.94, so rounded makes that 5 feet. Okay? Alright, I would like for you to try example 4. I'm going to give you a hint. Draw a picture first. Draw a picture first. Alright, let's see if you guys drew your picture properly. So we're going to draw a ramp, right angle, a height of 12 inches, and the angle is 17 degrees, and they are asking what this length L of the ramp will be. Okay? Alright, so let's stand at our angle. And if we stand here at my 17, I have the opposite. I need the hypotenuse. It's sine again. So sine 17 equals 12 over L. Alright, so our little trick of cross multiplying looks a little bit different here. So when I cross multiply, I get L sine 17 equals 12. Everybody okay with that? Now this is where something interesting occurs. This sine 17, those guys are kind of attached to each other. So I am going to divide by sine 17. Sine always has to have a number attached to it. It cannot do anything by itself. Okay? So now go to your calculator and type in 12 sine 17. Okay, and I got 3.5, so oh, nope, I didn't divide. Let's try that again. 12 divided by sine 17. I was thinking that's not right. Okay, I got 41 inches. Does that sound better? I hope so. Okay, so I hope you remember that stuff from geometry. This last page is something that is new. So I'm going to kind of talk through it for you. Okay, and I want you to look at it. So these are 3 new vocabulary words: cosecant, secant, and cotangent. Okay, so I'm going to read our definition. The cosecant of an angle is theta is the reciprocal of the sine function. So if you guys remember, sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. And secant is the reciprocal of cosine. So I hope you remember that reciprocal just means I turn the fraction over. So instead of it being adjacent over hypotenuse, it's hypotenuse over adjacent. And then the last one, cotangent of a function, is the reciprocal of the tangent. So instead of opposite over adjacent, I have adjacent over opposite. Okay? So it says find the remaining trig functions from example 1. So let's go back to example 1. That's this one. I'm going to get us some more space down here. Alright, so we want to write those 3 trig functions, our remaining ones. So sine matches with cosecant, so CSC theta. Cosine matches with secant, SEC theta. And tangent matches with cotangent, COT theta. Now, literally, guys, all you're going to do is flip the fraction over. So instead of it being 7 over 25, it's now 25 over 7. And instead of being 24 over 25, it's now 25 over 24. And instead of being 7 over 24, it's now 24 over 7. Okay? All these guys do is flip that fraction over. It's the reciprocal. Alright, so I'm going to go ahead and write cosecant theta, secant theta, and cotangent theta. And I want you to do the same thing for this one. Literally, we're just flipping our fractions over. So cosecant is 17 over 15. Secant is 17 over 8. And cotangent is 8 over 15. Okay? That's literally all you do. Alright, you guys have now enough knowledge to do assignment A8.1, and Mr. Nicer's going to write that on the board for you, and I will answer questions from it tomorrow. If you did not turn in your homework on Friday from Unit 7, you need to do that as well, and I will see you tomorrow.